Okie dokie, in this video, we'll be going through at least half of this quiz 4 practice for 1014. Let's get started with number 1. They say a nurse mixes 60 cc of a 50% saline solution with a 30% saline solution to produce a 35% saline solution. How much of the 30% solution should be used? So the way I see it is there's an amount of solution at 50%. And so what I'm calculating is like the amount of saline, like the physical amount, how many cc's of saline we have in the first solution. And then we have some amount with 30% saline. And then we have a total amount. So the sum of these will equal the total amount, which is 60 plus X. So this is the amount of cc's times the percentage, because it says it should produce a 35% solution. So this is the setup. This is an equation representing like the amount, the number of cc's of saline in the mix here. So let's calculate some stuff. We have 50% of 60 is 30. We have 0.3x. We have 60 times 0.35, which is something, plus 0.35x. Let's figure that out. Divide by 5. 12. Yeah, I got nothing. Let's try it out. Yeah, okay. 21. So now we're just solving for x at this point. So we subtract 0.3x, we get 0.05x. We subtract 21, we get 9. And we multiply by 20 or divide by 0.05, however you want to see it. So that's the same as multiplying by 20. So we get 9 times 20 is 180. And that is X, which again was the amount of the 30% saline solution. All right, let's keep going. This one really racked my brain on. I guess I wasn't taught ratios very well, so I will do my best. One custodian can vacuum the library in 1 hour. It takes a different custodian an hour and a half to vacuum the library. How long would it take them if they worked together? Okay, so we have one library vacuumed in 1 hour by the first guy, first custodian. We have the same library vacuumed in an hour and a half by the second custodian. Now think about this. The first custodian could vacuum the library and another half of the library in the same amount of time. The first custodian could vacuum one library. In other words, same amount of time, but 1.5 times more space is vacuumed by the first custodian. Same amount of time, 1.5 times more space is vacuumed. So what that means is when you split up the library between these two custodians, you need to make sure that the split makes sense with this ratio. The first, basically like whatever the slow custodian can vacuum, you need to make sure that the other custodian has 1.5 times that amount of space, because the first custodian can vacuum 150%, 1.5 times the space that the first one can in the same amount of time. So, what does this mean? So if we think about this as like percentage, I guess, like 100% being the entire library, we have 1.5x plus x equals 100% of the library. So like if we went ahead and just solve for x, we'd have 2.5x equals 100, divide by x, and you get, or divide by 2.5. And you get 40. So what does this mean? The x is 40. In other words, 40% of the library should be vacuumed by the slow custodian, the custodian. And then 60%, 1.5x, 1.5 times 40 is 60. So 60% of the library should be vacuumed by the fast guy, and then 40% by the turtle. So we have to think about how fast could bro with the 1 hour time do 60% of the library. Well, if the whole library, 100% of the library takes him an hour, then 60% of it would take him 0.60 of an hour. So 0.60 of 60 minutes would be 36 minutes. So this takes the first custodian 36 minutes. And again, the way we've constructed this is the first custodian can do that much space in 36 minutes in the time it takes the other custodian to vacuum this lesser space in the same amount of time. So like if you went ahead and did 0.4 of 90 minutes, the time it takes him to do the whole library, you should also get 36. So the total amount of time would be 72 minutes. I did my best with that. It's probably a drawn out explanation, but it works. So I'm going to go 72 minutes on that one. Let's get back to math here. So number 3, solve by applying the zero product property. So I think all that means is we want to start by getting everything on the same side so that we have everything here equal to 0. And then I think the idea is just to factor it. So we're just factoring this expression. We need y's. We need two numbers that multiply to negative 27 but add to 6. The only two numbers I can think of that multiply to 27 are 9 and 3. So to be specific, we're going to go positive 9 and negative 3, so that 9 minus 3 still gives us a positive 6. So the idea with this zero product property, I'm assuming, is if we want to know where this is equal to 0, in other words, where this product is equal to 0, well, all it takes is for either y plus 9 to be equal to 0, because that would make this equal to 0, which then when multiplied by this would make the whole thing 0, or you could have y minus 3 be equal to 0 for the same reason. If either of these is equal to 0, then it makes the whole thing equal to 0. So we solve for y and we get negative 9. We solve for y, we get 3. So negative 9 and 3 is our solution set. Can't do the squiggly, sorry. There you go. All right, that was number 3. Let's keep it going. Number 4, solve by using the square root property. I guess that just means we're taking the square root of both sides. So square root of a square just leaves us with k plus 9. Square root of 12, I'm going to go plus and minus square root of 12. Anytime you take a square root of both sides, we're going to do a plus and minus situation. So then we subtract 9, so we'll get negative 9 plus and minus the square root of 12. And I am going to leave it like that. So I'm going to say negative 9 plus and minus square root 12. Also, simplest form for the square root of 12 here. Square root of 12, or just 12, can be rewritten as 4 times 3, a product of a perfect square and a non-perfect square. The perfect square is intentional so that you can then take the square root of 4 and get 2, and then you leave the 3 on the inside. So 12 is equivalent to 2 root 3. So you do want to simplify that accordingly. So we're going to erase this and call it 2 root 3. So this is your solution set. Okay. All right. Let's see if we can do the rest. That's quadratic. I might end it there. Yeah, I'll finish these in the next video.